Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 242 Stone Game 8. So hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one, I actually spent way too long on the greedy solution. And the greedy was that I always just take the maximum score on the prefix sum. And that was just wrong. So it doesn't, you don't have to worry about that one or what that means. But you should know the prefix sum for this one, and there's a really weird this is the first observation you need to make about this problem, which is that, and don't look at the solution, don't peek at the solution quite yet, I'm just using this as scratch pad, but the idea is that, okay, let's say I make a move and I take the first four numbers, right? And in this case, four numbers is going to be 7, 5, 10, and -6, which is what, 16, say? So let's say, going up to here, the numbers are 16, right? The sum is 16. And then the next time, and then now you put 16 in the list instead. And then the next person, when they go, they will get to put in, 16. So their new list is this, right? And they have to take at least two numbers and so forth. So, for example, they could take these three numbers, and now they have 16 plus 5 minus 2, which is 19, and -6, right? But so the key observation here is using prefix sum, because you notice that the sum of these three numbers is just the sum of the first 7 numbers, right? So that's the key observation for me on this one. And it took me a little bit of mental thinking to prove myself that this is right, even though, if you're good in these kind of manipulations, then this is actually relatively straightforward, but I'm not, so it took a while. But yeah, so now that you have this, now you know how you can use prefix sum, which is, I'm not gonna go over prefix sum properties that detail in this one because there are a lot of problems on it. But this is how I did the prefix sum. I just calculate what it does is that the index of the index I is equal to the sum of the numbers from 0 to I minus 1 or something like that. Maybe it's off by 1, but you get the idea. And I actually had an off by 1 during this contest, so that was probably why. But yeah, so then now we construct a dynamic programming solution where I do it top down. And here I name it terribly go, but it's just, okay, what is the maximum score, which is the delta, starting on this index? And that's basically the how you would solve this problem. And okay, and I'm gonna kick it off by, the first person, Alice, has to always take the first two piles, and then on the third pile she has a decision, right? And this is kind of like, instead of writing if you do it naively, you may say, okay, I'll try taking 2 stones, I try taking 3 stones, and so forth, but that's going to run in n square, and n in this case is 10 to the 5th, and 10 to the 10 is really big, so we try to do this in linear time. And instead you do this thing where you cache the loops, and the idea is that, okay, let's say you already took the first 2 stones, right? And then what happens? What are your decisions? Your decision here is now either to take the third stone and then maybe keep going, or let the opponent take you end your turn here and let your opponent take starting from index. And in this case, what happens, right? Well, your score is now your current score minus your opponent's score, and your opponent's score is just going to be, this recursive thing plus the entire prefix, because this is basically taking all the numbers, including this one and the next one, right? Yeah, so basically this is taking the prefix, which is Because this is basically, I know I said the same things a couple times, sorry. I'm trying to figure out a cool way to say this, but this is the pile that you created by ending at index. So that's basically what this represents, and this is what you're forcing your opponent to take, right? And then now they have a, recursive decision to make in the future, whether they take, this is at least 2 piles. So this is your combined pile and 1 more pile at least, and then they could take either 2 piles or 3 piles by doing this, or they end, or more piles and so forth. So that's basically the idea behind this one. It's I know that I say it very, that's the thing with these dynamic programming problems, and I use LRU cache to cache this, because for every same index you get the same answer. And in this case, this is just a decorator in Python that let us cache the input and the output for that answer, so that if you see the same input, it will give the same output. But yeah, so this code is like 10 lines of code, or this particular chunk with comments or whatever and spaces. So it looks easy, and my explanation maybe, depending on how you want to go about it, like it could be easy or not, but it's a really hard problem. I spent about half an hour on this. I spent a lot of time debugging and getting with the wrong index, and also just also just like messing up with a greedy solution. But it's really hard, so take your time to really understand it and really draw it out. I think this part is okay. I think the hard part is this part, and really draw out what it means to end taking a pile, and try to figure that out. Because this is just combining the piles and then forcing the opponent to take those piles plus 1 more pile, and then they get that decision, right? So because the actual decision is whether you keep on going piles or you stop going to piles and then pass the turn. Cool. That's all I have for this problem. You could watch me solve it live in the contest and kind of see where I kind of struggle. And yeah, cool. See ya. Dumb. I'm dumb today. Okay, let's see. Catching up. How am I doing? This might take the entire time, probably. Wow. People solve this very quickly, so I gotta do it. I mean, this one was just a silly problem, though. I also took a long time to Q3. Don't know why. Okay. Oh, x has to be greater than 1. That's a weird problem. 10 to the 5th, so you can't really iterate testing it. Except for that, this is always going to prefix sum, so you can do the math on that. What I mean is that your sum is also going to be sum of the thing, so the delta is a little bit so the delta is going to be one of the numbers on the list. They don't tell you that, but Is it one? I mean, not necessarily one of the numbers on the list, but something like as a function. It's going to be some prefix chunk, maybe. Yikes. Let's start with the prefix sum, I guess. Okay. So greedy took the most. And then what happens? Let's say it's all positive numbers. What happens? Then you just take all the numbers. Let's say there's a negative number at the end and you stick them with it. What if there's a positive number in the end? Let's see. What if it's something like negative 105, then, and you know, whatever, then we take the thing, and then take the So basically you take the biggest number in the prefix. So your turn will always start with the big string. Okay. So greedily, you always take the biggest number in the prefix away. So you just have to keep on going from the right. Okay, so let's say you do greedy. So you do the greedy. So you take the biggest number into the thing. So then that's just a heap then, right? Let's try it out. So we want the biggest number. Let's just use sorted this again. What happens if we have tiebreaker? Do we want more numbers or that is a tricky one. And that depends on the parity of it, doesn't it? What's it do? Like they're all zeros, what do? You take all of them? You take all. Can't be convinced that that's the right answer. Now you take all of it because the invariant is that if otherwise the next person would just take the same value and your delta is 0, where if it's because of the monotonic yeah, you could do this with monotonic arrays, but I don't want to. So okay, so then in that case we want to sort it by the max index. Okay, that's fine. Okay, so okay. Maybe that doesn't matter. Maybe I'll fix it later. So you take the largest value. Really should use a heap actually. Fine. No, just keep it simple. If I is less, do you need to take at least 2? So if kun plus 2 is what? I don't even know what I'm thinking about anymore. Let's just do this problem. Just a header. I'm blanking it. Sort of containers. Okay, fine. Just see what terminates. That's fine. Oh yeah, okay, that's good too. Okay. Continue. Otherwise, code is equal to I, and then delta 10 times value, something like that. Why is that there? Oh. Yeah, it's gonna be messy, but yeah, for the first one you what? That's the 2. And that's why that part's a little bit off. So the last person has to take. No, I mean that's it then, right? So I took. Let's see. I mean, it's just really wrong, but so 0 and 1, so current you start at 0, so you want to go at least 1. So 1 is fine. Maybe? I don't know if that's right. I mean, it's better, but I don't know if it's right. So for number 2, how did I get 15? Taking me. Now this one takes to 21, which say what? So is that not greedy? Oh, I see. No, that's not right. Mm. Is that really the best? Is this 1, 16? One 16, 21. Okay, 621. And then the next guy 6, 9. don't get it though. Isn't that optimal? If I'm Alice and I take this is 1, 6. Right, because that's 21, and then so that's 2. Oh no, maybe not. It's 21 and then 19 and no, this is right. Oh, I see, because then Bob would actually take all of it and get 13 points. So then the delta is actually 6. Okay. So my greedy isn't right. My greedy isn't right, which is good that we resolve it here, but then how do you do it? How do you do? How do you do? That is an n square. Is it just DP? Maybe it's just DP and I made it too hard. But then it's also like a really messy DP that so basically, so if it's my turn, whatever. If it's my turn, I might have to change this to bottoms up, but okay. If it's my turn, then I either keep taking one more number. So my score is either you go this number plus because that's just me ticking this stone, or we go from, so now we end our turn here, so our score is set, and then the prefix of index. So this is the score for the opponent. So we subtract this as negative. It's a little bit off, I think, but let's see. Because you have to take at least one number. So, oh yeah. So so that's just wrong in general. That's the score. That's the score of the opponent. What's my score to get the delta? I'm not doing the delta right, I'm just doing the score. Well, the contribution would be the so this is the delta, maybe. Maybe not. No, I'm just being silly. So it can't. So we take and we add to the delta. Otherwise, we minus the delta. Do I just have the signs wrong? Nope. So the opponent takes it. Prefix. Okay, I think we're good here. Except for this. Why is it? Where do you even get 12? So we have to take at least one number so that okay. So this is at least 2. So this should be good maybe. But now worry about performance. Okay, I could also just try something like slow, but not that, but seems okay with respect to the time. So, okay. Let's just give it a try. Okay. Oof, this is hard. Hey, yeah, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know how you did on this contest. I did okay, but yeah. And also on this problem, what do you feel about my solution? Yeah, stay good, stay healthy, to good mental health, and I will see you later. Bye-bye.